When we think of Jupiter, what's the first thing that springs to mind? It's sheer size. Jupiter is the quintessential gas giant, a type of planet incredibly common throughout the universe. But don't be fooled, Jupiter is anything but ordinary. It's composed of nearly 90% hydrogen and about 10% helium, the same elements that make up stars. That's right. In fact, Jupiter's structure is quite similar to a small star. So, why hasn't it ignited like the Sun? Simple. It lacks the mass needed for nuclear fusion. Just imagine, if Jupiter were only a bit more massive, it might have become a second sun in our solar system. Instead, it remains a gas giant with no solid surface to land on, no place to stand. Now, picture this. What would happen if you tried to skydive into Jupiter? As you descend, the atmosphere thickens around you. At first, it feels like you're falling through clouds, soft, turbulent, but familiar. Then, suddenly, everything changes. The pressure intensifies, like a heavy weight pressing down from all sides. Soon you're trapped in a dense, thick layer of gas, unable to rise or sink further. It's as if you're floating in quicksand, and there's no escape. Even if you were aboard a spaceship, navigating Jupiter's atmosphere would be a nightmare. The powerful winds, sometimes reaching speeds of over 600 kilometers per hour, would pull you deeper and deeper. Temperatures would soar, and the crushing pressure would overwhelm your ship, ultimately reducing it to nothing. This planet isn't just massive, it's a perilous giant that shows no mercy. Let's talk numbers. Jupiter's diameter is more than 11 times that of Earth, around 139,820 kilometers. Its mass? A mind-blowing 318 times greater than Earth's. You could fit over 1,300 Earths inside Jupiter if it were hollow. Now let that sink in for a moment. It's a world of immense proportions, spinning on its axis at lightning speed. Jupiter rotates so quickly that its day lasts less than 10 hours, about 2.4 times shorter than a day on Earth. But that speed creates an incredible amount of momentum. What's it like to live on a planet that moves with such intensity? And what about gravity? Jupiter's gravity is 2.5 times stronger than Earth's. Imagine weighing 70 kilograms here on Earth. On Jupiter, you'd feel the crushing weight of 175 kilograms. But here's the twist. Since Jupiter has no solid surface, there's nowhere to feel this gravity. Scientists calculate it based on the atmospheric pressure at different depths. Pretty clever, right? And those clouds, what a sight to behold. From afar, Jupiter looks like a beautiful swirling tapestry of colors. But up close, it's chaos. Violent storms and jet streams move in opposite directions, creating weather patterns unlike anything on Earth. Scientists are still trying to figure out why these jet streams crisscross in such bizarre ways. What fuels these endless storms? Speaking of storms, we can't forget the Great Red Spot, a hurricane so large that it could swallow Earth whole. This storm has been raging for at least 300 years, and we still don't fully understand why. But that's just the tip of the iceberg. Jupiter's atmosphere crackles with lightning, some bolts 1,000 times more powerful than those on Earth. Imagine witnessing a storm like that. Electricity flashing across the sky, the winds howling louder than anything you've ever heard. Yet, even more powerful than its storms is Jupiter's magnetic field, the strongest of any planet in our solar system. It's generated by the swirling, electrically charged particles deep within its core. This magnetic field is 18,000 times stronger than Earth's, creating a massive bubble of protection around the planet. But it's not just a shield, it's a trap. Any charged particle that gets too close to Jupiter, whether it's an electron, proton, or even heavy atoms like sulfur and oxygen, gets caught in its magnetic grip. Much of this radiation comes from Jupiter's volcanic moon, Io, which continuously spews material into space. As these particles escape, Jupiter's magnetic field traps them, turning them into streams of radiation that bombard everything in their path. Imagine the challenge this creates for spacecraft. The Juno mission, currently orbiting Jupiter, faces radiation levels 10 million times stronger than a typical X-ray. To survive, it has to carefully avoid the most dangerous regions, while still getting close enough to gather data. It's like threading a needle in a storm of radiation. But Jupiter isn't just a hazard, it's also a protector. Its immense gravity helps stabilize the asteroid belt, preventing many asteroids from hurtling towards the inner planets, towards us. In a way, Jupiter is like a cosmic guardian, shielding Earth from potential destruction. But wait, if Jupiter is so massive, does that mean it's growing heavier over time as it pulls in more asteroids? The answer might surprise you. While Jupiter does collect mass, it's actually losing mass faster than it's gaining it. You see, the intense heat in its atmosphere causes gas molecules to move so quickly that some escape into space. On top of that, solar winds ionize its atmosphere, and lighter atoms like hydrogen are carried away by the magnetic field. In fact, Jupiter is gradually shrinking. It's losing mass every single day. This process is slow, almost imperceptible on human timescales, but make no mistake, Jupiter is shedding its weight, little by little. Over billions of years, what might that mean for its moons, its magnetic field, and its role as a cosmic protector? Could a lighter Jupiter become less effective at shielding us from potential threats? Jupiter's gradual loss of mass reminds us of the delicate balance that governs the cosmos. Even the mightiest planets aren't immune to change. As we continue to explore Jupiter, we're learning more not only about this giant, but also about the future of our solar system. What other secrets does it still hold? How might its evolution impact the rest of the planets, including our own Earth?